I am Dr. Suresh Thakur, your mentor, your tutor for chemistry. Today we will learn the relation between Ka and Kb. What is Ka? Dissociation constant of acid, and Kb, dissociation constant of base for an acid and its conjugate base. Let us consider a weak acid, Ha, which ionizes in water to give H3O plus aqueous and A negative aqueous. So Ka for given acid is equal to H3O plus ion concentration, A negative ion concentration divided by Ha concentration. Now, if it is an acid, so according to Bronsted-Lowry concept, if Ha is acid, then its conjugate base is A negative, because conjugate acid base pairs differ in one H plus ion. Acid has one more H plus ion than base. So you can see in A negative there is no H, in Ha there is one H. This is a monobasic acid. The acid which gives only one H plus ion is known as monoprotic or monobasic acid. Now, conjugate base. When conjugate base is dissolved in water, we will get Ha, because A negative ion accept H plus ion and gives OH negative ion. So in this way, Kb is equal to Ha into OH negative ion divided by A negative ion. Now you have Ka, Kb. This is dissociation constant of acid, and this one is dissociation constant of conjugate base. Dissociation constant of acid, dissociation constant of conjugate base. Now just multiply Ka and Kb. So Ka into Kb is equal to H3O plus into A negative divided by Ha into Ha OH negative divided by A negative. Now A negative cancelled by A negative, Ha cancelled by Ha. What is left? H3O plus and OH negative. So this equation Ka into Kb is equal to H3O plus ion concentration into OH negative, and what is this? Product of H3O plus and OH negative. We have already done it. Yes, it is Kw. So Ka into Kb is equal to Kw. That is ionic product of water. So this is the relation between Ka and Kb. Product of dissociation constant of acid and dissociation constant of conjugate base is equal to ionic product of water. And you know it is equal to 10 raised to power minus 14 at 298 Kelvin. To proceed further, taking log on both sides, log Ka into Kb equal to log of Kw. So it becomes log of Ka plus log of Kb, because it is log A into B. So log A into B is log A plus log B, and is equal to log of Kw. Multiply the whole equation with minus 1. So it becomes minus log of Ka plus minus log of Kb equal to minus log of Kw. What is this? Minus log of Ka is pKa, minus log of Kb is pKb, and minus log of Kw pKw. So pKa plus pKb is equal to pKw, and as Kw is equal to, because Kw is equal to 10 raised to power minus 14, so pKw equal to 14. This way pKa plus pKb is equal to 14 at 298 Kelvin. That's all about the relation between Ka and Kb for an acid and its conjugate base. Thank you very much for watching this video. If you like this, do press thumbs up button. God bless you all.